Alright, so here I want to look at the condensation polymerization in regards to the leave insert engineering theory, the polymers question, and the difference then between condensation polymerization along with addition polymerization. So the first thing to note with condensation polymerization is it's used to produce thermosetting plastics rather than addition polymerization. We use it to produce thermoplastics. Okay, so that's the main difference in regards to what we are looking at it for your paper. It's the difference in one, condensation is for thermosetting and addition is for thermoplastics. Now, condensation polymers are any kind of polymers formed through a condensation reaction. So this means in this process molecules are going to join together, but in the process they're also going to lose small molecules as byproducts, such as water or methanol. For what we're looking at, we're going to be looking at the production of phenylformaldehyde, okay, and the byproduct that's going to be produced here is going to be H2O or water. Now, phenylformaldehyde is also known as bakelite, and it's used in the handles of cooking pots or stuff like that. Okay, so it's a thermosetting plastic because if it's using the handles of cooking pots, we don't want it to deform easily under heat. And again, so we said thermoplastic is used to produce, is produced by condensation polymerization. Okay, so looking at the actual process. Now, so phenylformaldehyde, so here we have it here. I have the diagram down here, and that's what I have at this process here. Okay, so phenylformaldehyde is made up of two phenyl molecules combined with a formaldehyde molecule. Okay, so two phenyl molecules combined with a formaldehyde molecule. Now, looking at these closer, so the phenyl molecules, okay, so which is this one here, and it's also the ones on my left and right. So phenyl molecules are made up of 6 carbon atoms, 5 hydrogen atoms, and a hydroxide. Okay, so it's the phenyl group joined together by a hydroxy group. Now, here I have the black is represented carbon, white's represented hydrogen, red is representing oxygen, and green is representing the hydroxide or the OH. So, the first one, the phenyl molecules, are made up of 6 carbon atoms. Okay, so it's going to the formula for this is going to be C6H5OH. Okay, I'll just put that in bold. Okay, so C6H5OH. Where does this come from? So we see 6 carbon atoms. So we have 1, 2, 3, 4, 5, 6 carbon atoms. Okay, that's C6. H5. Okay, so 5 hydrogen atoms. 1, 2, 3, 4, 5. That's H5, and the OH represents my hydroxide or hydroxy group. Now, so we've two of these. We've two phenyl molecules. Where phenylformaldehyde is 2 phenyl molecules to 1 formaldehyde. So I have one here and one here. Okay. Now, looking at the formaldehyde structure. So formaldehyde is made up of 1 carbon atom, 2 hydrogen atoms, and 1 oxygen. Okay. So the formula for this is going to be CH2O. Okay, so this is the formula for our formaldehyde. Where does this come from? Okay, so we have 1 carbon atom, we have 2 hydrogen atoms, and we have 1 oxygen atom. Okay, so that's the makeup of the two different molecules. Now, so how do these join, and where am I getting my byproduct water? Where does this come out? Where's this coming from? Okay, so basically in the process, as these join together, we said that in condensation polymerization, okay, we said that is where molecules join together while losing small molecules as byproducts. So bringing that down here. So the molecules, the phenyl molecules are each going to give up 1 hydrogen atom, and the formaldehyde is going to give up an oxygen atom. Okay, so let's look at the formaldehyde or the phenyl molecules first. We're saying that these are each giving up a hydrogen atom. Okay, so I'm going to take this hydrogen atom here, and I'm taking this one here. Okay, I'll just put them up there. Okay. So now, there's my 2 hydrogen atoms taken away from my phenyl from my phenyl molecules. Now the next one is the formaldehyde gives up an oxygen atom. So I say in the red is represented formaldehyde. Okay, this is my formaldehyde molecule, and this is giving up a oxygen atom. Okay, so now this is what we're left with. Now, so these are all going to join up. Okay, so basically in the process, when these are joining, okay, so they're each giving up, and now as they do, this is going to join up here. Okay, so this is the formaldehyde molecule, and this other formaldehyde molecule is joining up here. Okay, so now this is the structure with what I'm left with. If we look at it down flat, and it looks the exact same as this here. So if we just break this in, so from this section we have my 1, 2, 3, 4, 5, 6 carbon atoms. Okay, we have our 2 hydrogen atoms, we have a carbon, and we have the other formaldehyde molecule here. Now where am I getting my H2O? Well, my byproduct that I took away, so I said I took 1 oxygen atom from the formaldehyde and 2 hydrogen atoms. They're all going to link up now. Okay, and then that's going to come here. Okay, so now what I have here is I have 2 hydrogen atoms, okay, and 1, so 2 hydrogen, which is H2, and 1 carbon atom, or 1 oxygen atom, sorry, which is O. Okay, and we know H2O is equal to water. Okay, and that's where I get my byproduct from. And this process continues and continues and continues as long as we need to until we get the desired product. Now, so condensation polymerization produces a network of primary bonded cross-linked molecules. Okay, so we know primary bonded cross-linked molecules are associated with thermosetting plastics. Okay, so they can't be reheated and reshaped. Okay, so once they're when they're heated, they're not going to reshape, they're just going to burn rather than be able to be reheated and reshaped. It's formed by stepped growth, unlike chain growth in addition polymerization. So what this means in addition polymerization, okay, so we see here chain growth, it basically meant that they were linking on one to the other. Okay, so there was only one point of contact, or one point where they could link on to each other. So each of the carbons could only link on to the next one at one point. Whereas in condensation polymerization, okay, so there's numerous different points where it can link. So I could have linked to this point, this point, this point, this point. Any of the hydrogen atoms I could have gave up. Okay, so this means that it's formed by step growth, and this produces a three-dimensional network. Okay, so we see it's a three-dimensional network. It'll start to come out, expand everywhere. Okay, so it's three-dimensional rather than in chain growth. It's usually a hard and rigid material, and as I said, so they're the properties associated with thermosetting plastics, and again, it cannot be softened by heating. Okay, so I hope this helps explain the process of condensation polymerization. And if anyone has any questions, please don't hesitate to contact me.